Hello everyone. Our today's A-level chemistry topic is organic nitrogen compound. Organic nitrogen compounds. These are those compounds which contain nitrogen atom, and specifically these are the amines. Amines. Those compounds which contain NH2 group, those are called as amines. Now, basically we know that there is a molecule ammonia, NH3. NH3. Now, depending upon the conditions, if from ammonia one hydrogen is replaced by alkyl group, for example, if one hydrogen is replaced from ammonia by methyl group, then this will be called as methylamine. If ethyl group is replaced by one hydrogen in ammonia, then this will be called as ethylamine. And if one hydrogen is replaced by the phenyl group, this is called as phenylamine. Different types of amines can be synthesized, can be formulated by variety of ways. Now, these are different types of amines depending upon the number of hydrogen atom replaced. There are 4 types of amines can be prepared. For example, if only one hydrogen atom is replaced by the alkyl group, for example, in ethylamine, in methylamine, in phenylamine, only one hydrogen is replaced by the alkyl groups or a phenyl group. All these are called as primary amines. Primary amines. All these are called as primary amines. If the second hydrogen is replaced by the different alkyl groups, for example, if I write here CH3, NH and CH3, this will be called as dimethylamine. Dimethylamine. Now, dimethylamine is the secondary amines, as only one hydrogen is left behind in ammonia molecule and other 2 hydrogen are all replaced by the alkyl group. That's why such type of the organic compound are termed as secondary amines. And if all the hydrogens are replaced from ammonia molecule by the alkyl groups, for example, this is CH3 and this is CH3 and CH3. This will be called as trimethylamine. Trimethylamine, and this is the example of tertiary amines. This is called as a tertiary amines. Now, it is most important to note that in all these ammonia and all amines, we know that there is always a lone pair present on nitrogen atom. In ammonia it is present also. In methylamine it is present also. In ethylamine lone pair is also present on nitrogen atom. In phenylamine it is also present. In case of secondary amines, in case of tertiary amines, all these contains lone pair on the nitrogen atom. Now, as nitrogen contains lone pair, so it means that it can also build up a dative bond or coordinate covalent bond with any other group producing quaternary ammonium ion. For example, if the same is produced just like this, if CH3, if this situation is created, CH3, and again nitrogen formulate another dative bond with CH3, then this will become a quaternary ammonium ion. And if, for example, Cl is attached with it to balance the charges present, this will be called as a tetramethyl quaternary ammonium chloride. Tetramethyl quaternary ammonium chloride. This will be the name of this organic compound having quaternary ammonium ion. Now, if we have to now discuss the basicity of amines. We know that all those substances which are electron pair donor, or all those substances which contain lone pair of electron which can be donated, those are called as bases, and these are Lewis bases. It means that ammonia, primary amines, secondary amines, tertiary amines, all these can behave just like bases. Now, if we compare the basic strength of the different amines, if we compare the basic strength of ammonia, methylamine, ethylamine, and phenylamine, then we can explain with the help of what is the nature of the group attached to amine group. For example, in case of ammonia, all the attached group are hydrogen. Hydrogen contain only one electron that is involved in the covalent bond formation with the nitrogen. That's why no more electrons are present in case of ammonia. That's why the behavior of this lone pair remains of only single nitrogen atom. That's why this will behave different. But what will happen if an alkyl group is attached? Now, the nature of the alkyl group is electron donating. Rather, we can say just like this. Rather, we can say that in case of methylamine, as we know that NHH, this is the structure of methylamine. Instead of, in comparison with both of these hydrogen, this alkyl group, methyl group, this contains large number of electron, more electron charge density, and as nitrogen is more electronegative, that's why it will attract all the electron charge density of alkyl group towards its, and we can say that the alkyl group behave just like an electron donor. Now, due to the increased electron charge density towards the nitrogen, the availability of this lone pair for the formation of dated bond or for the donation, it becomes easy. It means that alkyl group increases the capability of amines to donate a lone pair of electron. In other words, alkyl group increases the basic nature or basicity of amines. Now, in comparison with methylamine and ethylamine, definitely here are the more bulky group. More carbon atoms are present, that's why more electrons will be shifted towards the nitrogen, and automatically the capability of this amino group to donate this lone pair of electron become more easy. It means that basic nature is further increased. But what happens in this case? In case of phenylamine, we know that benzene ring contains a pi electron system which revolves over the entire benzene ring. Due to this pi electron system revolution, these pi electron system attract the pair of electron from this nitrogen and involve the pair of electron into the benzene ring 6 delocalized electron pair system. So the availability of lone pair of nitrogen in the presence of phenyl group become less. That's why the basic nature of a phenylamine decreases too much. So if we compare which is the strongest amine in all these four, this is the strongest one. And what is the next? Less strong is methylamine. What is the less strong? Less strong is ammonia. What is then less strong? This is the least basic amine in this group. Now this is the reason how the basicity of amine changes. But now, one thing more. If this is the most basic, but its basicity can also be increased further if we attach this nitrogen with another alkyl group. It means that the availability of electron becomes double from two sides from the alkyl group. That's why the donation of the lone pair of electron becomes too much easy, means basic character increases. So on the similar basis, we can say among all these, this is the strongest base, because all methyl group can provide electron directly to the nitrogen atom. In case of ethylamine, inductive effect involves, which decreases as the length of carbon atom chain increases. But in case of this trimethylamine, this is a tertiary amines, and all alkyl groups on direct linkage with the carbon atom provide electron directly to the nitrogen atom, increases the basic nature of the tertiary amines. In this manner, I have explained all these basic concepts regarding amines and their basic nature. Hope you have understood all these concepts. Please comment, like, share and subscribe my YouTube channel for the next upcoming video lectures. I thank you all.
Bilal.